Hello everyone, I'm Singh Gambhir, third year student at the IIT Allahabad. Welcome to our channel Learn Competitive Programming with CodeChef. If you are interested in competitive programming and want to learn and master data structures and algorithm, this is one-stop destination for you. Every week we will be posting explanations to CodeChef problems, conceptual videos, and also conduct live problem solving sessions. Before we get started, make sure to hit the subscribe button. Today we have the problem named uniform, which is an easy medium level problem and it is based on the connected components. I have used the disjoint set union to do so, but it can also be done with the help of graph traversals. But obviously the logic behind the question remains the same in any of the two ways. So let us see what problem has to say. There are C clubs in this school to participate and each of the student can be part of 0, 1 or even multiple clubs as well. There are a total of n students in the school and each of the student will be wearing shirts of one of the color from the list of m colors provided by the school. And there is one condition that the student of the same club should wear same color shirt. The student in the same club are given in this particular order that they can be represented as the continuous segments. So this one L1 to R1, this is the continuous set of students which are in the same club. Similarly L2 R2 till LX RX. And we need to determine the number of ways so that the student can choose their color of their shirts, keeping in this mind that the same club student, they need to wear the same color shirt. So we need to output the number of different ways to do so. This is the input format and we need to output it modulo on this number. So let us see what sample test cases have to say. This number 2 represents the number of club in this school. The number 6 represents the number of student in the school and the number 3, which is M, represents the total number of colors available for the shirts. Now for the first club, the student involved are ranging from 1 to 2 and then from 5 to 6. And for the second club, the student ranges from 4 to 6. So these are the students 2, 5 and 6. So for the first club, the student 1, 2, 5 and 6, these have to wear the same shirt, same colored shirt. And for the second club, the student 4, 5 and 6 have to wear the same colored shirt. Now suppose that this particular student, which is number 5, wears some colored shirt. Now obviously that particular colored shirt have to be wear by the student number 1, 2, 5 and 6 because these are in the same club, and as also this particular student number 5 is also the part of the second club, so 4, 5 and 6 are also required to wear the same colored shirt. So as these all the student ranging from 1 to 4, 5 and 6, so these all 5 students have to wear the same colored shirt. The number of options for this particular choice are m because they can choose out of the total m possibility for the color of the shirt. And the remaining student, which is the student number 3, now this particular student has also m number of choices in order to choose which color shirt he wants to wear. So the total number of possible values, like the possible cases, are m into m, and as here the value of m is 3, so we have 3 into 3, which is 9. So let us see how we can approach this particular question. So there were n total number of students, and suppose that these particular students are part of a particular club, and also there is a club which has some student common with this particular club. So we can conclude that as there are some students which are common to both of the clubs, so obviously these two clubs have to have the same colored shirt. So in this way, if two intervals of different clubs intersect, then these two clubs have to have the same colored shirt. Now suppose that we combine all of the clubs which have same colored shirt, and there are some number of these particular sets. Suppose we represent this as the component, and there are also some of the student which are not part of the any of the club. So number of ways to pick a particular color of shirt for this particular set, it will be m because it can pick like from any of the m particular color available. Similarly, there will be m option for this particular set of the club and m option for this particular set, and also there will be m options in order to choose a particular color from the set of m colors for this particular student. Similarly, for all of the students which are not in part of any sort of club, there will be independently m choices for each of those students. So summing up, the final answer, it will be m to the power number of component which there are plus the rest of the element which we have, because it is like m to the power component which we have multiply by m to the power rest of the number. So it is equivalent to m to the power component plus rest, where this particular term component represents the number of different sets which we can form, such that for a particular set it has all the clubs which are required to wear the same colored shirt. And this particular term rest represents number of such students which are not part in any sort of club. So we can calculate the number of different sets or the components with the help of disjoint set union. Initially all the clubs are in the different sets, and if we found out that two particular intervals of two different clubs are intersecting, then we need to take the union of those two clubs, and we just need to find out how many different clubs are intersecting with the help of their intervals. So let us see how we can do this particular thing. So let us see how the disjoint set union is helpful in this particular problem. Suppose that we have an interval which is of the club 1, and this is the interval of the club 2. And if these two intervals do not intersect, then nothing is required to be done. That is, no union operation is required to be performed in this particular case. But if suppose that there is an interval of club 1 and also interval of student of the club 2, and in this particular case if these two are intersecting, then union operation between club 1 and club 2 is required to have, because for this particular case the student for the club 1 as well as the club 2, they are required to have the same dress. If you see in this particular case, then the club 1 intersect with club 2 as well as the club 3. So union of 1 is required to be taken with 2 as well as with 3. Similarly, if we go on with the intersecting clubs for the club 2, then club 3 is the one which is intersecting with the club 2. So we need to take union of club 2 as well as the club 3. So if we see for this particular case, then all the students which are either of the member of club 1, club 2 or club 3 are required to have the same particular dress. But if we like apply the brute force solution and take each of the interval, and for every possible interval which is in the question, if we take on its intersection and check if it is intersecting, then we take union. So it will obviously be more time taking and it will not pass our solution. So let us see what more we can do and optimize this particular solution further. So if you see in this particular case only, we are taking union of club 1 with club 2 as well as with club 3. So by only this particular condition, club 1, 2 and 3 all are coming in a particular set only. This particular condition of club 2 intersecting with club 3 is redundant. If we do not apply this particular condition, then also this particular thing hold. What we can do is, suppose two particular clubs are intersecting, so we would combine these two clubs as a whole and then take intersection with other clubs, because already these two clubs are having the same colored uniform, so why to treat them differently? So what we were doing earlier, that considering club 1, and we will check for all of the remaining intervals that are they common with this particular interval or not. But suppose that we find some particular interval, say this particular interval of club 2 intersecting with this interval of club 1, then what we will do is that we will combine these two interval as one entity and take the bigger interval, and now we will treat them as one entity with any of the club 1 or club 2 as their club. So let us see with the help of an example. The first club has the student ranging from the number 1 to 3, and the second interval for the club 1 is from 13 to 13. Similarly, for the second club, the interval ranges from 2 to 6, for third club from 4 to 5, and for the fourth club we have the range from 6 to 11. Now, starting from the smallest value for the starting point of the interval, initially we will have this particular club 1 intersecting with the club 2. So now we will have a combined entity of these two with any of the club 1 or club 2 as their club, because that is equivalent only, because as these two are already intersecting, so club 1 is equivalent to club 2 in terms of the color of the shirt. Now suppose that any other interval intersect with this particular interval, then again we will include that particular interval also in this, and then again we will combine it with the club 3 as well. So the color for the shirt of the club 3 is also same as the of club 1 and club 2. Similarly, if there is also other intersection possible, as here the sixth student is also in common, so now this particular interval also is included in this. And now the club 4 will also have the same shirt as that of 1, 2 and 3. And now our entity, like the whole interval, ranges from 1 to 11. Now, as there are no other intersection possible, so these are only the set possible. So our set contains 1, 2 and 3 and 4 as the club. Let us see in this particular case only how we can calculate the remaining number of elements which are not in part of any sort of club. So if the two clubs are not intersecting, like the two ranges are not intersecting, then all the numbers in between those are not in part of any sort of club. But what happens to the elements which are present at the last? These are not in between any two intervals, so we need to include them separately. So let us see the code implementation of the same. For each of the test case, we will call the function name solved and also clear the global array, which is the immediate parent array. Now, this particular function make parent, it is like the standard function of the disjoint set union, which is used to initialize each of the set. The function find set is used to find the representative for that particular set which has the element x by going on to its immediate parent until we find the representative element. This particular function union is to take the union of those two sets which has the element x and element y. This is the standard modulo function which is used to take a to the power b modulo this number. Now comes the main part. For each of the test case, we will first take the input of C, N and M, resizing the immediate parent to the size C and also initializing our DSA. We will also maintain this particular list which will have all of the interval along with their club. So for each of the club, we will have this particular element x and then we will have x interval of j to k and we will store in this particular list in the form of interval and also their club number. We will sort this particular list so that we will have this particular j, which is the starting point of the interval in the increasing order only. Now we will initialize the elements of the previous club and previous start and previous end, which represents the interval which we have covered till this point. So as all of the numbers of the students start from 1, so we have initialized this thing with 0. Now, this rest is to calculate how many elements are there which are not part of any sort of club. Now, when we are traversing for each of the list, start represents the starting point of that particular interval and represents its ending point, where club represents the club number which the interval is. So, if the previous end which represents the previous interval, now if it is greater than equal to start, it means that these two interval are intersecting. So we need to take union of these two clubs, the previous club and the current club, and now we need to expand our interval. So the previous end, it will equal to the max of previous end or the current end. We can also take the starting as the minimum of the two, but it will not be required because we are already traversing in the increasing order of the starting interval. So it is like redundant if you do so. Also, we can update the previous club as club. It is like based on our choice. If you want, you need to update this particular club, so you can, and if you don't want, so you do not do this, because it is like redundant only, because already these two club, the previous club and club, are in the same set only. So if you take its union with another set, so you can consider any of the two. So if you want, you can use this line, or you can also omit this particular line. Now if these two intervals are non-intersecting, then we need to add rest with this particular amount, which is the number of element in between these two interval, because these are the elements which are not in any sort of interval. So these are like clubless, and if it is not intersecting to be, so we need to update our variables, the previous start, previous and the previous club. Now as we have already discussed that we need to also add this particular term, which is n minus previous end, because these are the elements which are not in any sort of, means it is not in between any two clubs, so these elements are needed to be added extra. One thing is to note is there, when we are considering the first interval, then also there are some elements which are on the left of this particular interval, but they are already covered because we have considered that our previous interval starts from 0 to 0, so they are already covered. The only remaining elements were at the right of the last interval. Now we need to find how many different sets are there. So for each of the club, we will find the leader element for that particular club, and we need to take out the size, like how many different leader elements are there, and also we need to add this particular element, which is the number of elements which are not part of any sort of club, and our final answer is m to the power this particular element. And finally we need to print this thing. So let us submit our code. Also, did you know that CodeChef also conduct free live classes on an academy where we teach every possible topic related to competitive programming? These courses are conducted by top coding experts who have been ICPC World finalists and are also highly rated on various coding websites. You can use my referral code MEET10 to subscribe and get an instant 10% off. We have an AC. That's it for this one. Make sure to hit the like button if you get something out of it. Do submit your code even after the contest, and in any case of doubt or feedback, feel free to leave in the comments.